Hi, we're going to be starting our introduction to the unit circle and try to find out what the values are on the unit circle. But before we do that, we need to try to figure out how do we section this unit circle up. Now, there's some things that we do know. We do know that 2 pi is equal to 360 degrees. We don't want to think in degrees anymore. We want to change our way of thinking and over to radians. So if we go all the way around the circle, then we would have radians. And so full circle, 2 pi. And so what I do then is I start thinking about what different angle measurements I would have in and around the circle, but now in radians. And so if I section this out, some information that I need to do is that I want to split this up into what we traditionally think of as 45-degree angles, but now we're going to talk about pi over 4. So what I want to do is I want to split the circle into 8 congruent parts. So 2 pi divided by 8 would give me pi over 4. So each time that I split this circle up, I'm going to use a pi over 4 measurement. Now some other well, let me start with some of this then. And so if I look at this we start at 0. This is 0 radians. It's also 0 degrees. Then as we work our way around the circle, we know that 180 degrees is also pi. So halfway around is going to be pi. Then all the way back to here would be 2 pi. Now on the unit circle has a radius of 1. That's why we call it the unit circle. Has a radius of 1. And with that situation, the arc length that's on this outside of the circle, when that is equal to the radius, then the sweeping out inside here of our angle would be 1 radian in measurement. And so when I put these labels around the outside of the unit circle, that also means how far did we sweep out on the inside in a traditional angle measurement and what you think of with degrees, but now it will be with radians. So I want to split this unit circle up. And I said pi over 4. So if this is pi over here, and I want to split this pi into 4 congruent pieces. Now I'm not going to be perfect here because I'm just drawing on this, but I'm going to have one piece right here. So I split this quadrant into 2 congruent pieces, and I'm going to split the second quadrant into 2 congruent pieces as well. So that would represent pi over 4. So when I label this on the outside, I'm going to put a pi over 4 on the outside, but that also represents this angle measurement on the inside. So when I do this, I like to count in and around the circle. And so if I figure out these different measurements, I just start counting. One of these slices of pizza, so to speak, is pi over 4. So I'm going to go 1 pi over 4, 2 pi's over 4, which we can reduce to pi over 2. Then this would be 3 pi's over 4. 4 pi's over 4 is pi. And you can think of what we're going to get here. And then this one would be 6 pi over 4, which we reduce down to 3 pi over 2. And then I put 1 back over here, which would give me 7 pi over 4. I think this one is off a little bit. I don't like that one, so I'll make it a little bit better. All right, there. So each one of these angle measurements going around would give us a different value. Now we can go in positive direction is going to be counterclockwise. If we go clockwise, then it's going to be a negative angle measurement. So you got to figure out which direction you're going. Now I could continue on counting. The circle I can whip around it an infinite number of times. So if I'm counting these things, this would be 1 pi over 4, 2 pi's over 4, 3 pi's, so on. This is 7 pi over 4. This one would be 8 pi over 4, which is reduced to 2 pi. Then I can go to 9 pi over 4, 10 pi over 4, 11 pi over 4, 12 pi over 4, and so on. And I can just keep on going around the circle this way. Now if I go in a clockwise direction, starting at 0, this angle measurement here, this side, would also be the same thing as negative pi over 4. So sometimes you'll see this called 7 pi over 4, and sometimes you'll see this as negative pi over 4. It all depends upon the direction and where you end up. And so I can count around the circle, negative pi over 4, negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4, negative 5 pi over 4. So if I say 3 pi over 4 or negative 5 pi over 4, I'm going to end up on this side of my angle measurement. The ending point is called the terminal side. The starting point is called the initial side. So 3 pi over 4 and 5 pi over 4 have the same terminal side. We can do the same exact thing for this other circle that I have down below, but instead of splitting up the circle into 8 congruent pieces, I'm going to try to split it up into 12 congruent pieces. So if I have 2 pi divided by 12, each one of those angle measurements would be pi over 6. So if I go here again, this is 0, this is pi. I look at my semicircle, and I'm going to split it up into 6 congruent pieces. Now I'm going to be stretched here a little bit to get this perfectly accurate. There would be 1, 2, and 3. So I'm splitting it up into 6 congruent pieces, 1, 2, 3, 4, 5, and 6. So I took pi and I split it into 6 pieces. So this would be pi over 6. Remember, that is the sweeping out as well. And on the unit circle, it is this arc length too. So now I start counting again.
Just a reminder of the college fair out.
So now I'm counting pi over 6, 2 pi's over 6. So if I put 2 pi over 6, oops, I don't want to do that because I want to reduce that. So instead of putting 2 pi over 6, I'm going to put pi over 3. So this would be pi over 6, pi over 3, 3 pi, this would be pi over 2 reduced. So I'm up to 3 pi over 6, 4 pi over 6, 5 pi over 6, and 6 pi over 6, which is pi again. Then if I go down into the third quadrant and split this up, this one was at 6 pi over 6, so this would be 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, and 11 pi over 6. 12 pi over 6 brings me back to 2 pi. Now, just like we could do with the pi over 4, I can go in reverse direction. So this angle measurement right here would be negative pi over 6, negative 2 pi, negative pi over 3, negative pi over 2, and so on. So that's how we split up these unit circles. The next thing that we want to do is, since we do have it on the unit circle, we want to figure out what are the x and y coordinates at each one of these points. If we can do that, then we create what we call the sine function and the cosine function, where we can read off right off the unit circle what the coordinates are. The x coordinate is going to be your cosine, the y coordinate is going to be your sine. And so if I go back up here, well, let me go down here, we need some information. For this one, for the top one, we need a special right triangle. And I can draw it like that, or I can draw it like this. This way is probably better. Since I'm on the unit circle, what I want to do is I want to try to create this triangle so I can plug it in onto my unit circle. This hypotenuse is going to have a length of 1. which is equivalent to the radius. And so if I figure out the other two sides using Pythagorean theorem, you know that this has a special ratio. If this is a 45, 45, 90, this would be 1, and then this one would be square root of 2 over 2. And this one would be square root of 2 over 2. It's a right isosceles triangle. These would be the proportions. You can double check this. A squared plus b squared is equal to c squared. Square root of 2 over 2 is the same thing as square root of 1/2. We neglect that fact a lot of times, but really in simple form, this is just square root of 0.5. Same exact thing. Now down here, what we're going to have is a 30, 60, 90. That's in our old language, but now it's pi over 6, pi over 3. So still my hypotenuse is 1, but I have to figure out these other measurements. If you think of this as being an equilateral triangle, and I'm only taking out half of this piece would be 1/2. Then this piece here would be, if you do Pythagorean theorem on this one, it'd have to be square root of 3 over 2. Those are the proportional sides for 30, 60, 90. So whenever I have pi over 6, pi over 3, or anything that's divided by 6, anything that's divided by 3 in reduced form, I'm going to get x and y coordinates of 1/2 square root of 3 over 2. Now I could also lay this triangle down. It'll be exactly the same. Make that a little bit better. And then this one would be 1/2. This one would be square root of 3 over 2, and this would be 1. Hypotenuse would be 1. So long leg square root of 3 over 2, short leg is 1/2. Now what I want to do is I want to fit each one of these special triangles onto my graph up here. And so I'm going to do the one in the first quadrant, this one here. Because I want to get the coordinates of this point. So if we look at this one forms a 45, 45, 90. And this is a right triangle here. And remember our hypotenuse is 1, and so this is square root of 2 over 2, square root of 2 over 2. So if I look at the values of the x and y coordinates of this point on the unit circle, it's going to be square root of 2 over 2, comma, square root of 2 over 2. This one up here is going to be 0, 1. That's a quadrantal angle. Quadrantal angle means that it's on the axis. This one over here, now it's in the second quadrant. So if I'm going to get the points for this would be negative square root of 2 over 2, comma, positive square root of 2 over 2. This point here would be negative 1, 0. This one is in the third quadrant, so I'm looking at negative square root of 2 over 2, negative square root of 2 over 2. You should be familiar with this stuff. Maybe not so much the radian measure, but all these coordinates of these points. This one would be 0, negative 1. That's another quadrantal angle. And then this one, I'm in the fourth quadrant, so this one would be positive, negative. So all I did was I used this idea of this triangle. I could cut this out. I usually have students cut this out, and then they can flip it over. They can put it over here. They can put it over here. Each one of these forms a 45, 45, 90 angle or triangle, and so the proportions of these sides are always going to be the same. So now what will happen eventually is that I'm going to ask you what's the cosine of 7 pi over 4. The cosine is the x-coordinate at 7 pi over 4, so you're going to tell me that it's positive square root of 2 over 2. So you go to 7 pi over 4 and read off the x-coordinate. If I ask you what's the sine of 7 pi over 4, you're going to go to 7 pi over 4 and you're going to read off the y-coordinate, which in this case would be negative square root of 2 over 2. That's why we're putting all these triangles and circles together. Now if we go back to the other triangle, which is the 30, 60, 90, that's our other special triangle, we can fill out this bottom this bottom unit circle in a similar fashion. So if I look at this one, at pi over 6, I know that pi over 6, I'm going to be forming my 30, 60, 90. It is laying down here. I guess this line should be probably a little bit more up and down. Yeah, that's better. Maybe still a little bit crooked, but all right. All right, so then the height of this one would be 1/2, and then this one would be square root of 3 over 2. Long leg, square root of 3 over 2. Short leg would be 1/2. So if I want to get the coordinates of this point, it's going to be the x. Let me use a different color. The coordinates of this point, that didn't change for me, would be square root of 3 over 2, 1/2. That would be that point in there. Now if I go to pi over 3, my drawing is going to get really messed up here if I keep on drawing on it. But what will happen now is that I'm going to have a 30, 60, 90 triangle that's going to be standing up. So the x coordinate is going to be the short leg, and the y coordinate is going to be the long leg. So the coordinates of this would just flip-flop. So it would be 1/2 short leg, and then square root of 3 over 2 long leg for that point. Then the quadrantal angle stays the same. The coordinates of this point would be 0, 1. This one, let me just get all of these other ones in here. I'm in second quadrant, so it's going to be negative 1/2 square root of 3 over 2. This one would be negative square root of 3 over 2, comma 1/2. Remember, it's going to be long leg, short leg. And this one here would be negative square root of 3 over 2, negative 1/2, because I'm in the third quadrant, and I'm on the axis system for the circle. This one would be negative 1/2, negative square root of 3 over 2. And this one would be positive 1/2, negative square root of 3 over 2. And this one would be square root of 3 over 2, negative 1/2. So these are special trig values that we're going to be using quite a bit. There are an infinite number of other trig values that we can use. Your calculator will spit a lot of those out for you. So these are not the only trig values that you'll ever see, but right now they're the specific main ones that we want to try to use. And so when we set this up, I'm going to go back to the worksheet that you have, and then we're going to replicate these values again all together on one piece, and then we're going to try to fill in our chart of our sine and cosine values. Remember that the cosine of some theta, this is an angle measurement, theta, is equal to our x coordinate, and the sine of theta is going to be equal to our y coordinate. If you remember that, it's very easy. You go to the angle measurement, read off the x coordinate, and now you have the cosine of theta. Okay, let's put the values now on the unit circle here. Maybe we can make this a little bit more organized, but at this point now, what we have is, this one is pi over 6. And at pi over 6, remember, the coordinates are, I'm going to go square root of 3 over 2, comma 1/2. Long leg, short leg. Square root of 3 over 2, comma 1/2. Then this one would be isosceles right triangle, which would be my pi over 4. So at pi over 4, I'm going to be same for the x and y coordinates. And then this one would be pi over 3, which would give me 1/2, comma square root of 3 over 2. And this one would be, we should use this one as well. This one's pi over 2, which gives me 0, 1. Now, oh, I forget what this one is. Let me see if I can count. Okay, so this would be pi over 6, 2 pi's over 6, 3 pi's over 6, 4 pi's over 6. So this one here is going to be 2 pi over 3. 2 pi over 3 would equate to short leg, long leg. Then this one would be 1 pi over 4, 2 pi's over 4. So over here we'd have 3 pi over 4. Also, I know it's a fraction that's just under 1. And I know that 1 pi is down here, so I'm going to be in the second quadrant. 2/3 pi is over a half. 3/4 pi is over a half pi. So you should be able to figure out where you're at. And so this one would be negative square root of 2 over 2, square root of 2 over 2. I made a mistake here at 2 pi over 3. I forgot the negative. I'm in the second quadrant, so I need the negative there. And then this one would be a little bit under 1, so it's 5/6 pi. And so I'm going to go to negative square root of 3 over 2, comma, 1/2. So those are my values there. Then if I keep on going on, this one's a little bit more than 1, so it's 7 pi over 6, which would give me negative square root of 3 over 2, negative 1/2. This one would be 5 pi over 4, just a little bit more than 1, which gives me negative square root of 2 over 2, negative square root of 2 over 2. So this one here. And then this one here would be, I'm getting up to 3 pi over 2, so it's 7 pi over 6. 8 pi over 6 becomes 4 pi over 3, which is negative 1/2, negative square root of 3 over 2. Now I have these running together, which isn't so good here. Let me put 3 pi over 2 up inside, 3 pi over 2, which gives me 0, negative 1. This one here would be 4 pi over 3, so I'm going to 5 pi over 3 now. So 5 pi over 3 would be 1/2, comma, negative square root of 3 over 2. This one would be, it's over 4, so it's 7 pi over 4, which would give me square root of 2 over 2, negative square root of 2 over 2. And this one would be 11 pi over 6, which gives me square root of 3 over 2, comma, 1/2. And here's another quadrantal angle. This is 0 or 2 pi. And for that one, that would give me 1, 0. So now what we want to do is we want to get an example of graphing this thing. To graph this, you want to graph square root of 2 over 2 or square root of 3 over 2. You probably need a decimal approximation. So if you go to your calculator, you can double check this, but square root of 2 over 2 is approximately 0.7071. Square root of 3 over 2 is approximately 0.8660. 1/2 is exactly 0.5, and 0 and 1 are what they are. So for instance, if I want the sine of 0, sine of 0 means to go to 0, and I want to read off the y-coordinate. So the sine of 0 is going to be 0. Sine, remember, is the y-coordinate. Cosine is the x-coordinate off of the unit circle. And so if I go to pi over 6, read off the y-coordinate, 1/2. Pi over 4 would be squared. Oh, we want to graph this, right? So I can't use square root of 2 over 2 too much, so it's going to be 0.7. Pi over 3, and I'm really approximating there, but a pi over 3, the y-coordinate would be square root of 3 over 2, so 0.86 or 87, however you want to look at it. And then this one would be 1. 2 pi over 3 would be 0.86. 3 pi over 4 would be 0.7. 5 pi over 6 would be 0.5. Pi, I didn't write these coordinates in here, so this would be negative 1, 0. So I'm back at 0. 7 pi over 6 would be negative 0.5. You see how this just goes up, down, and it keeps on going down. I guess there's a pattern here. Negative 0.5, negative 0.7, negative 0.86, 3 pi over 2 would be negative 1. Then I go back up, 0.7, and 2 pi I know is 0, and so here this one should be negative 0.86. So you can plot those points to graph this on the curve below. Now the cosine, let me see if it changes color for me this time. The cosine is going to be the x-coordinate. So I'm going to read this off. This is 1, and so then it's 0.86. And you could probably fill this in yourself. In fact, I'm going to pause this, and you can go ahead and try to figure it out, and then I'll show you the result after we're done. Now I filled in the cosine. To get the tangent, you got to do the y-coordinates divided by the x-coordinates at any particular point. And so it's going to be sine divided by the cosine, which is y over x. Same thing. So if I take this here, I take 0 divided by 1, and that's going to give me 0. If I take 1/2 divided by the square root of 3 over 2, I'm going to go here on the side here and see how this works. 1/2 divided by square root of 3 over 2. If I cancel this one out, the 2's cancel, so I'm left with 1 over the square root of 3. Many times you'll see this as square root of 3 over 3. I guess I don't care which way you do this, but then you can put it into your calculator. 1 divided by square root of 3, and you get 0.577. Now you can do the same thing down the line and fill in the values for the tangent. Now you can complete that, and you're going to have to graph the tangent here in a little bit, but ultimately what we want to do is stretch these graphs out. In order to stretch these graphs out, what we're doing is we're taking this x-axis here and taking the angle measurements. Sometimes they call this an unwrapping function, but we're taking the x-axis and putting the angle measurements there, and then we're going to put the y values here are the values of the sine and cosine. So if I want to graph y equals sine of x, that's the same thing as y equals sine of theta. It depends what you put on this axis. But here we got the x. So we're going to be graphing y equals sine x. So I'm going to put the first point here, 0, 0. So this would be my x-coordinates here. Now this is kind of confusing because I just said that the x's are the cosine. Well, now I'm on a different axis system. So I'm saying that the x is my angle measurement, and the y is going to be the sine of this value. Later on we'll graph the cosine of that value. So this would be 0, 0 is what I'm going to graph. Then the next point would be pi over 6, comma, 1/2. Pi over 6, remember, is splitting this thing into many different pieces, 6 pieces, 1, 2, 3, 4, 5, 6. So at pi over 6, I'm going to plot 1/2, which would be approximately there, and all you can do is approximate it. Then at pi over 4 is halfway here, would be 0.7. That's 0.75, so it's going to be just a little bit under that. And at pi over 3, I'm going to be at 0.860, which is approximately there, and then 0, 1 would be there. Then I go back down, 0.7, so I got a nice little symmetry here about pi over 2, and then 0.5, and then I go to 0. And then I continue on with these different values. When I graph this, then it's going to be a smooth curve. So what we did was we took the values off the unit circle, and now we're plotting them on an XY coordinate system. You can complete this one and complete this worksheet the same way using your data table here. Sorry, you got to flip back and forth, but sometimes when you find the patterns, then you can go on from there. One other thing about this tangent, make sure that when you divide by 0, this would be undefined. And when it's undefined, we're going to get a vertical asymptote. And remember, we can't divide by 0. So finish up this worksheet, and I'll try to post the key, but you should be able to do most of this. I assume you have some familiarity with this, maybe not so much with the radians, but you've graphed these things before. Thanks. Let me show you a couple things that are happening here and what we're doing. This is a Ferris wheel. And what we can do is we can look at this little car, and this can replicate the unit circle. Unit circle, the sine value is the height off the ground of this little red dot. So right now it's at 0, and now it's going up, and then it's coming up to pi over 2. So when I graph the sine function, I can use this picture. Now look at what happens when I turn this and just follow that red dot. What does it do? Well, it goes up and down, right? So right now I'm at times 0, so I'm starting in the middle, then it's going to go up, and then it's going to go back down. This is a little bit slower. Now over time, and that's what you're kind of spreading this out, over time what I'm doing is I'm splitting out this graph. And so instead of doing it straight up and down here, I want to see how it actually goes. And so when I graph this, here would be the 0. I'm going to stretch this out over time. I can't draw on this one, but this is what I'm doing. So over time, it's going to go up to 1, slow down, and then get a little bit faster down to 0, and so on. That's how we're graphing. If you want to look at the real graph here, this is 0 to 360, but we're doing it in radians. This little red piece here represents the y-coordinate. This little red piece here, once again, represents the sine. So all I'm doing is I'm stretching this out and unwrapping this off of the unit circle. And so when we graph this, it just takes the y values off the unit circle and then plots them over. Before I was using the word time, but yeah, it could be time or else it's this angle measurement. You can check these out yourself by, I just Googled trig applets, and I think the first one that shows up is this one. It's ies.co. You could type all this in, but trig applets, and it should be the first one that shows up.